Hello, welcome to Engineers Mindset. Now we have a problem which says a train starts from rest and accelerates uniformly at 2 meters per second until it attains a maximum velocity in 20 seconds. If it maintains this velocity for 60 seconds and then returns uniformly to rest after a further 20 seconds. After a further 20 seconds, the first question says draw a graph of the motion, and the next question says use the graph to determine A, maximum velocity reached, B, retardation, C, distance covered during each stage of the motion, and D, finally, total distance covered. All right, before we start this problem, if you're new to the channel, please don't fail to subscribe. Of course, don't fail to subscribe and share the videos if you find it very interesting. All right, so we'll start by plotting the diagram. So the first question says we should plot the graph. So I, graph of motion. Okay, so we'll start by plotting the graph of the motion. So let's say this is our graph. Okay, this is velocity v, because the velocity time graph, while this is the time in seconds t. This is the origin, so everything is 0 from the origin. Now the train starts from rest, which means it starts from the origin and accelerates till it reaches a maximum velocity. So let's keep it here. Let's call this the maximum velocity. So this is the maximum velocity, v max, or you can say v1. Okay, and it attains this velocity in 20 seconds. So the time it takes to reach this velocity is actually this is the time axis and this is the velocity axis. So this time is 20 seconds. Now it maintains the speed. Remember, first of all, it's, as it says, uniform motion. Now uniform motion simply means that the speed at the beginning is same thing as the speed at the end. So it maintains the speed till the next further 60 seconds. So the speed was maintained. So meaning that if this V max, let's say here is V1, it was maintained till V2 for the next 60 seconds. So for the next 60 seconds from the question, it says for 60 seconds. Now 60 seconds, we have to add that 60 seconds to these 20 seconds. So 60 plus 20 gives us 80. So it means the time it takes to reach this point is actually 80 seconds. Okay, so here is 80 seconds. So take note, this motion was made for the next 60 seconds. So 60 plus the 20 seconds it has already covered here gives us 80. Now it retards from the question. It says it retards and comes to rest in the next 20 seconds. Okay, so retardation, it means it comes to rest from this point in the next 20 seconds. So next 20 seconds simply means, remember we have 80 here, so next 20 seconds means 20 plus this 80. It means the time it takes to come to rest is actually 100 seconds. Okay, take note of that. So this is the velocity time graph. So that's the graph of the motion. All right, now the next question says we should use the graph to obtain maximum velocity reached. So A, maximum velocity. Okay, you know that acceleration A is simply velocity all over time. Acceleration is simply velocity over time. So this simply implies that velocity itself will be acceleration times time. If you cross multiply, time multiplied by acceleration will give us velocity. Okay, so that means now that velocity is now equal to, acceleration was given as 2 meters per second. Time it takes to achieve this maximum velocity, the time it takes to achieve maximum velocity is simply 20 seconds. So the time it takes to get to this maximum velocity is simply 20 seconds. So 2 times 20, that simply implies that maximum velocity is actually 40 meters per second. Now this maximum velocity is what we call v1 here. Okay, and the uniform was maintained, the motion was maintained uniformly to v2. So it means v1 is equal to v2. So v1 and v2 are the same and the value remains 40 meters per second. It's a uniform motion, so the first speed is equal to the next speed. Also, even without solving, since it's uniform as well, it also means that the acceleration from the first motion, is also the same as acceleration during retardation. So you will have the same value for acceleration during retardation. Okay. All right. So the next question says we should obtain retardation. Okay. Now retardation is simply negative acceleration. Retardation. Okay. And retardation took place at this point. Okay. So retardation is simply negative acceleration. So let's use AR for retardation, and it's simply maximum of velocity at point 2, which is this, all over the time it takes to come to rest. Okay, and this is equal to velocity at point 2 is same thing as velocity at point 1. Remember, it's uniform motion, so the two velocities are equal, and we had the value to be 40 meters per second divided by the time it takes to come to rest. Okay, it was given as 20 seconds, and we can as well obtain that here. If here is 80 and here is 100, it means time it takes to come to rest is 100 minus 80, which is 20 seconds. So here is 20 seconds. That's the time it takes to come to rest. It was given in the question. So this is actually 40 divided by 20. And therefore, retardation is simply 2 meters per second. So I told you, acceleration, since the motion is uniform, it means acceleration from beginning is also same thing as retardation at the end, or acceleration at the end. It's still the same thing. It's not going to change because motion is uniform. Just like velocity v1 is equal to velocity at point 2, since motion is uniform. Okay, so take note, velocity, acceleration is simply velocity at point 2 divided by the time it takes to come to rest. That's what retardation is all about. And the velocity at point 2 is same as velocity at point 1, which is 40 meters per second, divided by the time it takes to come to rest. From the graph, here is 80 and here is 100. So to get this time from this point to this point simply means 100 minus 80, and that's 20. And it was given to us in the question. It came to rest in further 20 seconds. Okay, so we achieved this. Okay, next question says we should calculate distance covered during each stage. So let's call here stage 1, because actually it was 3 stages. First stage was from rest to achieve a maximum velocity in 20 seconds. The next stage was from 20 seconds again down to next 60 seconds, which we added to 20 gave us 80, and then finally the next 20 seconds, which we added to 80, which gives us 100. So it means we actually have 3 stages for the motion. So this is stage 1, and this is stage 2, and this is stage 3 for the motion. Okay, so let's now consider stage 1. C, distance during each stage of motion, distance for each stage. Okay, so let's consider stage 1. Now a critical look at stage 1 shows that the motion of stage 1 from origin to a maximum velocity, and it took place in 10 seconds. This is triangular in shape. This is stage 1, and stage 1 is triangular in shape. So let's pull it out. For stage 1, this is what we have. Okay, so these are origin 0 down to 20 seconds. So from this point to this point is actually 20 seconds, and this is our velocity. The value of our velocity is maximum v1. It was given to us as, we've solved it as 40 meters per second, so we'll have 40 meters per second, which is our velocity. Okay, so since this shape is triangular, it means that distance for stage 1, let's call it x1, is going to be the area of the shape, and area of a triangle is half base times height. So distance for stage 1 is going to be half, the base is the time, and the time is 20 seconds, times 20 times height. Height is the maximum velocity, which is 40. So distance for stage 1 is simply half times 20 is 10 times 40, so which implies that distance for stage 1 is simply 400 meters. So that's distance for stage 1. So let's find distance for stage 2. Okay, for stage 2, let's now see what we'll have at stage 2. At stage 2 is simply from 20 down to 80, and of course, looking at this shape, we have rectangular shape. This shape is rectangular in nature, so we'll pull it out. So this is what we'll have. We have a rectangle for stage 2. Okay, we have a rectangle. and of course this height still remains v1, which is the maximum velocity. So the height is the maximum velocity and the value is 40 meters per second. 40 meters per second. Similarly, at this point is 20 seconds. Now if from the origin down to this point is 80 seconds, and then from the origin down to this point is 20 seconds, it means distance from 20 to point 8 is simply 80 minus 20. It was given to us in the question as 60, so 80 minus 20 will also give us 60. So the time it takes to cover this motion is 60 seconds. Okay, so we'll have here to be 60 seconds. So just like in the first case, distance of stage 2, x2, is also going to be the area of the shape, and area of a rectangle is simply length times breadth. So s2 is simply length is given as 60 seconds, is 60 times breadth is the depth, which is 40 times 40, of course. So that means that distance covered for stage 2 is simply 60 times 40. That's about so that's 2,400 meters. 2,400 meters. So distance for stage 2 is actually 2,400 meters. And then the final stage, which is stage 3. So for stage 3, also let's take a look at the diagram. Stage 3 is also triangular in shape, which is from 800 down to from 80 seconds down to 100 seconds, and then it's triangular in shape. So let's pull out the triangle and see. We have this. Okay, the height remains the maximum value of velocity, which is 40 meters per second. Now this distance, remember that here is 80 and here is 100, so that means distance from this point to this point is simply 100 minus 80, which is 20 seconds. We've already found this. Okay, so we have the time to be 20 seconds. All right, so since this shape is triangular, it means distance for stage 3 is also going to be the area of the shape, which is half base times height. So x3 is equal to half base is 20 seconds, height is 40. So x3 is obviously 10 by 40, which is actually 400 meters. So you have this. So distance for stage 3 is also 400 meters. Okay, so that's the distance covered during each stage of the motion. Finally, next question says we should calculate the total distance covered. All right, so total distance covered, that's d. Total distance covered, x total, let's use st, is going to be the sum of the total distances, for each stage. So we have s1 plus s2 plus s3. So total distance st, s1 is we'll put s1 as 400 meters. So you have 400 plus s2 was given as 2,400 meters plus 2,400 plus s3 is also 400 plus 400, so which means total distance covered st is actually 2,800, 3,200 meters. All right guys, that's it. I hope you find this video very interesting. Please do subscribe to the channel and share to your friends for more subscribers. I will see you in the next video. Thanks and cheers.